Today we are going to discuss one of the important topic, that is a finite state machine. So finite state machine is nothing but in previously we in the counter on anything. So we have discussed everything with the help of the numerical output. So here we will discuss something initially with the state diagram and the output and input relationship. So here let's take a traffic system. So this is traffic system. So red light, red, green, yellow. So this logic. So red is at S1, green is at S2 and yellow is at S3. Okay, so this is the case. So S1 will be in the same state for 20 seconds. So it will be in the same state for 20 seconds, and after the 20 seconds it will be going to red green state. So then it will be stay there in a 20 seconds, and after 20 seconds it will be going to S3 and it will stay there 20 seconds and it will again go to S1. So this is how that any kind of system or any kind of problem, any real world scenario can be able to represent this in the form of finite state machine. So that is what we have done here. So there is two types of finite state machine that we can do. The one is Mealy and one is Moore. So the difference between Mealy and Moore machine is that the output depends on present input and present state in the Mealy, where in the Moore system the output depends only on the present state. Okay. Here the clock is asynchronous in nature with the output. Here the output is synchronized with the clock. In Mealy machine the circuit designing is very complex, but in Moore machine the circuit design will be very simple. The input can be affect directly. The input can directly affect the output in Mealy machine. So there is a less noise immunity. But here the input cannot affect the output directly. So there will be more noise immunity in the Moore system. Okay. So less number of states compared to Moore. So less flip flop. So Mealy has less number of flip flops and less number of states. So there we will be designing it in a very easier manner. It means the requirement of flip flop will be very minimum. So let's see how we can design a Mealy state machine. So here we have took one analogy where it will be in initially it was in S0 state. So when input is 0, corresponding output will be 0 and it will be in the same S0 state. So this is how the Mealy machine will be represented. This is our input, this is output. So this will be in the same format. When input is 1, when it is in current state is S0, the next state will be S1 and the corresponding output is 1. So similarly we will be going through all the states. So number of states is equal to 3. So number of flip flops required is 2. So let us fill this table and let us design the Mealy state machine circuit. So thing is that, so here initially it is in S0. So when input x is equal to 0, it will be in the same state. So that will be S0. When input is 1, it will be going to state S1. So when the input, when it is in S0 state and input is x0, output is 0. When input is 1, the output is 1. I hope you guys are able to know how we can fill this one. So similarly, if it is in S1, if the x is equal to 0, then it will be in same state. When x is equal to 1, it will be going to next state S2. So corresponding output will be 1, 0. So similarly, when it is in S2, when whatever may be the condition, even it is 1 or 0, it will be moving to S0 state and corresponding output will be also 0. So this is what the table that we will be filling for here. So here we have to take one assumption that QA, QB. So we have to now change the states into some respective levels. So I am taking 0, 0, 0, 1, 1, 0. Okay. So this is S0. So this is S1 and this is S2. Okay. So we need to assume this one. So any types of number you can take it, that is depending on your thing. So I am taking this to make it easier to understand. Let me erasing the few things. So let me erase this also. So here is the thing is that, so we are taking S0 which is equal to 0, 0 and here taking S1 which is equal to 0, 1 and S2 which is equal to 1, 0. So let me change this table to bigger one. So that we can able to find out the equations for everything. Okay. So this is present state. So this is next state and this is inputs. So next state we can be representing that with the QB, QA, because now we are going to convert this with the flip flop. So here also QB, QA, and input is X and the output is Z. So we need to find DB and DA input. So once we find out the equation for DB, DA, then our Mealy state machine diagram is ready. So let us take the thing. So first it is in S0. So S0 now can be written as 0, 0, 0, 0. When input is 0, when input is 1. So what will happen when input is 0, it will be in the same state, so that will be 0 0. Corresponding output will be 0. When input is 1, it will be changed to next state, that is 0 1. The corresponding output is 1. This is how we need to fill everything. So let me complete the rest of the table. So you guys can also pause the video and try to complete here. So this will be very easy. So simple conversion from this to here. So this will be quite simple. So when the input is 0 here, this will be going to 0 1 and the corresponding output is 1. When one input is 1, this will be going to 1 0 and the corresponding output is 0. So here it is 0 1 0 1 and the corresponding thing is that it will be 0 0, output will be also 0. So here it will be 0 0, output will also be 0 0. So when it is in S2 and the input is 0, then it is going to the next state, that is x0. So it will be going to x0, the thing. But here we have to take another one assumption, that 1 1 which is state is not allowed here, means it is not present here. So if the state is coming, so we have to consider this as x. So then you can take this as a don't care condition, because the state is not present here. So as the flip flop has the 4 input state, but we have only 3 states, so this can be taken into x. So now we need to find dA and dB with the help of the K-map. So we need to find out 3 equations. So this is 1, so this is 2, and this is 3. So this is very simple. So simple K-map, we guys can able to do it. So before that, let me use the excitation table and fill the dB and dA. So what are the things in QA? QB will come in dA, and what are the thing and thing that will come here. So let me complete the table. So here will be 0 0 0 1 0 0 x x. So here it will be 0 1 1 0 0 0 x x. Why we are writing directly is that from the flip flop we guys already know, in D flip flop what are the next stage output, that is from the input. So that is what we take this. So if we use the K map and find out, we will be getting the equations, that is z which will be equal to z, this one. So this one with the help with the comparing with present state. So z which will be equal to q b bar q a bar plus into x. X will be also taken into account because x is a input, right? So x will also be taken. So x plus q a x bar. So this is the thing for z, and dB which is equal to qa x. So dA which will be equal to qb bar qa bar plus qa z bar. Okay, so these are the equation for z and everything. So from here we are going to design our Mealy system. So let us take a fresh diagram. So in order to represent the circuit here, so we have find out all the equations. So from there we are just going to build our system in this black box. Simple. Okay, so here we will be having 2 inputs, one is x and another one is QA/QB, that will be the output state machine that need to be fed back to the thing. So here for the x we will be getting z, so these two things is fixed. So now we need to design a system to get z and inputs to the flip flops. So let me draw the flip flops also. So here one flip flop, here one flip flop, so 2 flip flops is there, right? So one flip flop, let me adjust the things. So here 2 flip flops synchronized with the same clock because this is a Mealy system. So this will be the same clock. Okay, so let me connect this to your clock. So this is dB, so this is qb, so this is qb bar dA qa qa bar. Okay, so simple. So now let us first define our z. So we know the equation for z which is equal to, so z is equal to qb bar qa bar x plus qa x bar. So now let's draw this one. So let us assume that we have qb bar readily available. So means that we need to couple it back here, so that I will do it later. So qa bar x input. So 3 are given to a AND gate. So 3 input AND gate, and that need to be added to OR. So XR and an inverter. So X and an inverter is there. So inverter. So here AND gate, and that will be given to here. So this one is z. So z can be directly now given here. So z is given. So this one is also equal to what? So this one is also equal to dA. So dA, which is also same as z. So what we can do? So we can take this one and we can fit the to ZDA. Okay. So now QB we have to design. QB, which is equal to QA into X. So here another one, that is QA X. So let us give this to two input AND gate, and let us fit this into the system. Okay, so this is how it will come. So now we have completely designed everything. Now the thing is that the QA, QB, Q thing, these things need to be fed back to the system. So let us take the things. So it need to be, so let's take it as it is legacy. So think that this need to be come to this input. Okay, so this is QA bar. So now we have to connect QB bar. So which is also simple like this. So this is how and Mealy machine can be built. So any state of things that you can take. So based upon things and analysis, we can design any kind of circuit that is needed. So I hope you guys now have some idea like how we can design a Mealy machine. Okay, so this is how. So things is that, so this is equal to QB, this is QB bar, so this is QA bar, this is QA. So this is QA bar. I made a mistake here. So this is QA, this is QA bar. Okay. So this is how a Mealy state machine can be built. So thing is that you have to remember how we can achieve this with the help of this table. So with the help of this table only we can achieve the thing. So please make a note of it. So I think you guys have a good idea now how to design a thing. So next class let's discuss how the more state machine can be designed. So more state machine design is further more easy, not complicated like this. So let's discuss that in next class. Thank you guys. Stay tuned, like, share and subscribe our channel.